in this question, we're asked first of all to express g of t as the sum of an odd function and an even function. So for part 1 we should expand the brackets and find that g of t is equal to then t cubed times cos 3t plus t cubed times t, which gives us t to the 4, minus 2 times cos 3t, and lastly minus 2 times t, so minus 2t. Then we need to realise that t cubed is an odd function, which we can illustrate briefly. If t is 1, t cubed would be plus 1. If t is minus 1, t cubed is minus 1. If t is 0, t cubed is 0, and the function looks something like that. In other words, it's antisymmetric, or you could say that f of t is equal to the minus f of minus t. So t cubed is an odd function. Cos 3t is an even function because any cosine term is symmetrical about the vertical axis, or we could say that f of t is equal to f of minus t. But the upshot is that an odd function times an even function gives us an odd function, so the first part, the first term, is part of the odd function. The other part of the odd function is the constant minus 2 times the odd function t. Well, we know t is an odd function. We have f of t equals t. It's just a straight line, 45 degrees, or gradient 1. And it's odd because it's antisymmetric. We took this part and reflected it in the vertical axis, and in the horizontal axis we'd get the whole of the function. Or we could say that f of t is equal to minus f of minus t. In other words, if we think of f of t as being the vertical distance from the horizontal axis, that distance there for t is the same as the negative of that distance there for minus t. In other words, t itself is an odd function, and any constant times that odd function is also an odd function, so the whole of our odd function is t cubed cos 3t minus 2t. So that's the odd part. The even part, any even power of t is going to be part of the even function, and also any constant times the cosine term will also be even. As we know, any cosine term is symmetrical about the vertical axis. So that's the even part. And in part 2, we're asked to find the integral across the symmetrical limits of g of t, and it's helpful then to know that the integral of an odd function, or an odd term of a function across symmetric limits, is 0. So we can discount the first term, the odd term, and only have to think of this, that the integral from minus 1 to 1 of the even part of g of t is the same, if you look in your notes, as double the half range integral, and our even part is t to the 4 minus 2 times cosine of 3t, all with respect to t. Integral of t to the 4 is we'll increase the power by 1, divide by the new power, so t to the 5 upon 5. Integral of minus 2 cos 3t, we'll put the minus 2 down straight away. We need to divide by the multiplier of t, so minus 2/3, and integral of the cosine term is a sine, and the argument doesn't change, it stays as 3t. Square brackets, now we've done the integration, and put the limits on the right hand side. Put the top limit in, replace t with 1, and we get 1/5 sine of, minus 2/3 sine of 3. Put the bottom limit in, and both of these terms, t to the power 5 upon 5 is 0, and also sine of 0 is 0. So that's our final answer then, 1/5 minus 2/3 of sine 3.